Hello students, so today we will be discussing about the second mathematics chapter of class 9, polynomials. Polynomials. Before talking about polynomials, let us go a step further back and talk about algebraic expression. So what is algebraic expression? An algebraic expression is a combination of some algebraical identities like some parts ax plus by plus c, where each of these are called as terms. These are terms. They might have separate or equal number of exponents. Now, an algebraic expression cannot be directly termed as polynomial. The first and foremost thing that we should see in a algebraic expression is that this exponent m and that exponent n, these must be whole numbers. Whole numbers, yes, they cannot be negative, they cannot be fractions, they cannot be decimal. We can term an algebraic expression as polynomial only if the exponents of the variables are whole numbers. Variables means this x is a variable, this y is a variable. Variables are those terms that can be changed. But this term a, b, c, these are called constants. There are two parts of an algebraic expression. One is constant and the other is variable. Constants are generally known while variables are to be found out during the algebraic calculations. Now let us take an example, polynomial like 2x square plus x. So this can be termed as a polynomial because here in this case the exponent is 2, here in this case the exponent is 1, though it's not written there. So both 1 and 2 are whole numbers, so we can term it as a polynomial. But if it was like 2x square plus root x, in this case the exponent is 2, but for this root x it actually means x to the power half. Half is not a whole number, so we cannot term it as a polynomial. So the simplest way of identifying a polynomial is that find out the variable, check whether the exponents of the variables are whole numbers or not. If they are whole numbers, they are polynomials. If they are not, then they are not polynomials. Now the polynomials can be divided into many categories basing on certain quantities they have. Like, first of all, we need to see ax plus by, ax plus by plus c. So we can observe that there are three examples where all of them are polynomials, but there is a difference. The difference in the number of terms. So we can differentiate polynomials, different polynomials, in the terms of their number of terms. Like it's only one, so we will call it monomial. There are two terms, we will call it binomial. There are three terms, we will call it trinomial. So all these are on the basis of number of terms. Now let us take another example, ax plus by plus c, another ax square plus by plus c, ax cube plus by plus c. So all of them are now trinomials, but the varying thing that we see here is that the power of, or the exponent of x, here it is 1, here it is 2, here it is 3. So the highest power of the variable in this case is found to be 1, in this case it's 2, in this case it is 3. So these are called degree of the polynomial. The highest power of a polynomial is called degree of the polynomial. In this case it is 1, in that case it is 2, in that case it is 3. So we can name them on the basis of their degrees. This example where the degree is 1, it's called linear polynomial. Here it's called quadratic. Here it's called cubic. So these are on the basis of what? These are on the basis of degrees. Now these are variables having two. We have polynomials here. These are having two variables. We can have polynomials with one variable, two variable, three variable, or many number of variables. Apart from these, there are some polynomials, some special polynomials called constant polynomials. In this case, what happens is that we don't need any variable. It can be any constant, 2, 3, 100, it may be A, B, C, or anything like that. Just we should not have any variable in this case. Or another special case is zero polynomial. So what is zero polynomial? The number 0 itself is called zero polynomial. There is only one zero polynomial, the number 0 itself and nothing else. So these are the basic things about polynomials, and let us take an example how to find out the polynomials. Suppose we have x plus 2, we have 2 root x plus 1, we have root 2y plus 1, and another one, suppose z plus 2 by z. So how to say which of these are polynomial and which of these are not? Like in this case, the exponent is 1. So it's a whole number. This is a constant. We should not look about it. So it's a polynomial. Here the exponent is half, which is not a whole number. So this is not a polynomial. Here the root, the radical sign is only with the number and not with the variable. So this is a polynomial. Here it is actually z plus 2z to the power minus 1. This variable has power 1, no problem, but this is minus 1, which is not a whole number. So we cannot consider this to be a polynomial. This is not a polynomial. So that's it for today. Thank you.